This is Jim Morentz of the XchangeCore community. I want to welcome all of you today to what's a very interesting program. One of the things that we've done over the last little bit of time is to implement a GeoJSON output from XchangeCore. And if we could go to the topic slide. One of the things that GeoJSON does is allow a lot more flexibility. It is a standard of the Open Geospatial Consortium and of other international standards organizations. And it provides a rich way to concisely explain and provide data. Data can sit inside of a database in many different forms, a SQL or non-SQL or a traditional database. But when you bring it out, it needs to be in some type of a format that is agreed upon. And GeoJSON is one of those formats. It's new to XchangeCore over the last several months. And in fact, it's a great result of the XchangeCore community because it was started by a group of graduate students at the University of Illinois at Chicago. And I mentor a master's degree class out there. And one of their assignments was to explore adding GeoJSON into XchangeCore over a series of, I think, 2 or 3 semesters. They got a pretty good product running. And then it needed to be improved and really sort of made less a science experiment and more of a production system. And through the California Earthquake Clearinghouse, which had received a grant from the FEMA's Earthquake Hazards Reduction Program, we were able to get a little bit of money to apply to the GeoJSON output. And then finally, the last piece of it came during the hurricanes. And we've got a little project going with the Department of Homeland Security, Science and Technology for improving SABRE operations. And this GeoJSON output was made specific and turned into production quality through a little bit of that effort just over the last few weeks during the hurricanes. So that's how this new output arrived. And the reason that it arrived is because ArcGIS Online, probably the most popular of common operating picture tools, does a better job with GeoJSON than it does with a couple of the other feeds that are common, let's call them. RSS feeds, GeoRSS feeds, have been around for 15 years. ArcGIS Online brings them in, but doesn't give you a whole lot of capability to work with those. Other format is KML, which you use in Google Earth and a number of other applications, Google Maps and others. Again, very common format, has been out for well over a decade, and it can bring it in very easily into ArcGIS, but you don't work with it very well. Well, GeoJSON is a database structure that ArcGIS likes better, and it allows you to do a lot more with it once it comes in. It doesn't come in quite as easily as the GeoRSS and KML feeds because it is not anticipated to be a live source of data by ArcGIS. Rather, it is seen as a file. XchangeCore produces it as a live feed. You can go back and you can hit it every 15 seconds if you want to and get anything that has changed during that period of time. So we built the GeoJSON to be much more like a KML or an RSS in being able to be a live feed, live source of data, which sort of serves as a front end for touching the database. Right, your query goes off the GeoJSON processor, that touches the database. As a result, you can do it a lot, you can do it easily, and you can do it with virtually no knowledge at all except to paste a URL, as we'll see in a minute, to be able to get that data out. So the real reason for doing this is to get the most future-looking GeoJSON format and to give better data that ArcGIS Online uses better to be able to do better visualization, better analysis, and be able to integrate better by forming its own feature service out of the GeoJSON data. And that's what we're going to learn about. First thing we're going to hear, and we're fortunate to have Phil Beilin, who is the GIS coordinator for Walnut Creek, California, to teach us about this. Phil has been involved with XchangeCore for 6-7 years now through his work with the California Earthquake Clearinghouse. He is I'm going to butcher the title, but he's the chairperson of the Northern California Public Safety GIS group, and as a result is intimately involved with public safety GIS, which often translates to being ArcGIS Online. And Phil also has been an avid user of spot-on response and all the other tools that are associated with both SABRE and the work that the Clearinghouse has been doing. So very happy to have Phil here today. And he's going to take us through 3 different steps here. One is a quick look at how you grab the GeoJSON from XchangeCore, and then moving that into ArcGIS Online to create a feature service, and then to manipulate that data to show the value of the additional GeoJSON and compared to some of the other formats that ArcGIS consumes. And then after doing that, I asked Phil to take a look back since he's been working this ArcGIS XchangeCore connection for years now, to go back and take a look at some of the previous exercises and real emergencies that he's been involved in, and just continue the discussion of saying, okay, here are the things that you can do with data that comes out of XchangeCore to enrich it, give it analytical capabilities, give it more understanding, give it the context by bringing in other layers of information and making it part of a complete analysis. And after that, we'll open it up to questions and discussion. And at this point, let me turn it over to Phil Beilin, a great resource that we can all benefit from. And there is his email address, because you probably will want to contact him. So Phil, it's all yours.
Thank you, Jim. Thanks very much. And again, my name is Phil Beilin. I work for the city of Walnut Creek, but as many of us, we also wear several hats. And one of them is, and it's recently changed to the National Alliance of Public Safety GIS, is the national group of public safety GIS folks that work on developing best practices. And out here in the West Coast, we have, after the EPA Region 9, we have a Region 9 group, and I co-lead that with a colleague that's at Cal OES. But again, our focus out here is understanding of how to make the best use of GIS data for public safety purposes, and sharing with each other in a multidisciplinary, multi-level of government way. We recognize that though each of us may be developing data for our own agencies, we need to be aware that many other agencies may rely on our information for doing analysis, and an ability to know about what you can do with the information, how to discover it, and how to use it is really important. And that's what I'm going to talk today and show you. And before I do that, though, I'm going to, as Jim mentioned, explain how this GeoJSON is brought into an ArcGIS Online environment. And for both the state exercises that I've been involved with and even some real events, you know, most of us use more than one tool. ArcGIS Online is one tool. Sometimes we need greater analytical functionality, and we use ArcGIS Desktop or other flavors of software. We also use Google Earth. We use spot-on response. There's different viewers, but again, it comes down a lot to being able to discover the data, know, is it vetted, is it coming from an authoritative person, and then how to make use of it. And then how do decision makers want to summarize the data? So involved in that is, okay, we get it in this format, in this color, maybe it's symbolized. Can we change it to make it a standard format that our decision makers want to see? And I'll come up with that in a little bit. So let me go in and explain that the GeoJSON file coming out of XchangeCore and discovered through spot-on response When you process it, you want to be able to do things like you see here in this ArcGIS Online map that I've made. I'm starting off just to show you where we're headed. We're headed in a way in which we can take a field such as the activity category and then display the data, these 1,200 events coming from the Sabre community, from representing the box stores and restaurants and gas, and be able to symbolize them as we need to. And the way that all starts out is a discovering of this GeoJSON file. And the GeoJSON file is coming, again, out of Spot On Response. You get a URL. I'll just break it down so you can see it here. So I get an email to discover it this way, or I use Spot On Response. But one way or the other, I end up copying the URL for this live feed of information. It's live at this point. And then what I'm going to do is copy it in a browser, and it looks like this. It's just GeoJSON text. I need a file that I can import into ArcGIS Online. So from here, I'm going to save this as a GeoJSON file. And then once it's saved, I'm going to go into ArcGIS Online, and I'm going to import it. And the way that I import it is I go Add Item from my computer. I choose the file. Here's the file that I had already saved, the GeoJSON feed. I then add it. It takes sometimes a little bit to load, so I'm not going to have you wait for that to happen. But once it's loaded, it ends up, and this data set is right here, getting created as both a GeoJSON file, but also converted to this feature layer that's hosted in ArcGIS Online. And this is really important in that what you can do with it has a lot to do with a particular software's ability to translate it and understand it. And what we've been able to do in this particular version of GeoJSON, like I said, is to bring it into ArcGIS Online in a way that you get the attributes nicely parsed out. The information that's supposed to be text is text. Things that are supposed to be integers are integers. I'm going to go behind the scenes a little bit now to show you what that will look like. Originally, when you bring in that file into ArcGIS Online, they come in as a single layer. But again, one of the functionalities that we make use of is, hey, this recognizes a lot of these attributes, and it can symbolize this information based on these fields. So I can change the symbology, which is what I did in ArcGIS Online, to take a data set that all looks the same. I've labeled it with this particular field, but if I tell it to look at the category text, then you can start to see, and I'll show you the legend of what that looks like again. It breaks up all these many thousands of, sometimes thousands of layers as to the particular stores. And again, this is feeding in stores that are closed in this case, okay, or chain stores that are closed in this case. Another thing that you can do is if you just want to look at a subset of them, you can filter them, as I have done here, where I'm just looking at target stores that are closed. So depending on what your need is, the strength of this is that the information comes in a way where the database, the table, the fields of information are available to me. And then depending on the software that you're using, and in this case we're using ArcGIS Online, I'm able to label things, I'm able to summarize things. If there was a field of how many employees were here, I could select it and summarize or aggregate, well, how many employees are not working right now because these things are closed. Again, what you can do with this data is an exact representation of what the software can do. So this is what we did here. And as Jim mentioned, there are other kinds of feeds of data, but different feeds of data you can do different things with. Here's a KML feed, same information from the Irma hurricane. And notice that when I click to be able to do stuff to it, there's not an ability to open an attribute table, which is what you could do in this other feed here, is that when you clicked on or when you highlighted this, you could see the attribute tables available to me. Okay, so different formats of files give you different functionalities, and one needs to be aware of this. Many people want to use KML. Our California National Guard, one of the key formats they use is a KML file for Google Earth. So one needs to be able to take a data set, you need to prepare it so that it can be exported so that people can save it as other formats, which is what we did in the recent California fires for the National Guard, is that we took one format of file, and because that flavor of file allowed us to export it, we could then check it out or change it out, reformat it into another feed that could feed another service. So that capability is something that's really important to be able to do. Now, there are attributes, of course, in a KML file. Everybody knows that. It's just that they're kind of buried in this software, and you can't really do a whole lot of analysis with this. I would need to take the KML file, feed it into something like ArcMap desktop software, process it, and then republish it to be able to get at a lot of these fields here. So that's a bit about the different formats and the way a GeoJSON file is coming. One of the things I wanted to show you is how we've been taking data discovered through XchangeCore and combine it with other information in over the last couple years of both earthquake exercises that, as Jim mentioned, I'm part of the California Earthquake Clearinghouse. So we've successfully shown how we can get data from the field in both real events as well as exercises, bring it through XchangeCore, bring it up in ArcGIS Online, have these data streams coming to us. So I'm going to show you several. One is from the work that we did with the National Guard in the 2015 exercise that they did. Let me bring up that browser here. This was a capstone exercise. This is one of my first introductions to using ArcGIS Online and XchangeCore. And in this case, what we had and what you're looking at is a screen of Southern California. I'm going to zoom out a little bit just to give you context. So here's LA, and what we have in those little orange dots are many of the California healthcare facilities. So we have a live stream coming from the California Department of Public Health. We have a simulated plume of information that was modeled and brought in. And then we even have, you can see in the legend here, a live stream of weather data coming from NOAA. And again, our intent here is to combine with different agents from different agencies, the data sets that they're making available to be able to answer the decision makers' questions. We can get overwhelmed with too many layers of information, and what we need to recognize is that there's some really core decisions that need to be made and need to understand what layers of information, whether they're timely or not, and whether they're authoritative or not, and then how to combine them in a meaningful way for a decision maker to figure out maybe what resources are needed in a response. Or in something like this, are there healthcare facilities in the plume? And what we did in this exercise was to use the plume boundary. So we needed to enable the plume boundary to be selected, and then said, well, show me all the healthcare facilities within a particular, and these different colors represent, in the plume's case, different levels of concentration called AGLEs. And so we would select one and then select the healthcare facilities within it. We then used XchangeCore functionality to push this data of selected values out so that other people could see that. And that was one example. Another case that we did was with the National Guard, is that they did just last year, Vigilant 17 was an earthquake exercise where there was a major earthquake simulated in Southern California. And by the way, they also had one day later in Las Vegas. But again, the work that we were involved with was how the information is developed and how to share it. And in one case during the exercise, one of the decision makers asked, can we show the airports and simulate some of them being closed and some of them being open? And what we were able to do is to grab somebody's feed. The Caltrans, our California Transportation Department, had a feed at airports. They allowed it to be exported, which allowed me to add a field that wasn't there before for status. And you can see down in the table, if I move over a little bit, that I added a field of status. And so the simulators in the exercise were able to tell me which airports were closed and open. I was able to then symbolize the airports based on whether they were closed, and then push out, again, through XchangeCore, those that were open and closed. And that was one kind of information. We had a lot of other information that we were putting up for that exercise. Here's another instance where the National Guard was using it. I was sitting with them in their fusion center, and we were combining our different data sets. Again, in these exercises, success looks like you practice sharing data between a civilian side and many of the civilian agencies, as well as in this case, since this was led by the National Guard, the National Guard. So our ability to take National Guard data, bring it into ArcGIS Online, take data from the civilian side, and give it to the National Guard into their different formats sometimes was a level of success. And in this exercise, and again, now I'm just getting into showing you different kinds of data that we were simulating. We simulated if there was a particular hazardous material plume, that we could display that. We could see if the plume were their National Guard resources. These blue icons are the National Guard resources. It should show, well, it will show up in the legend if I go down here, but these are National Guard resources. And let's see. So that's some of the information I wanted to show you. There are just different kinds of layers. Again, in this case, we were looking at the Weather Service. We were also just practicing how long does it take us to get from one agency a plume data and put it out. And we're starting to recognize that many of these data sets are not intuitive in terms of being able to, when they come out of a model, be able to select a particular concentration, use it to then select stuff that's within it. So again, this practice is what's very, very important to do. The next thing I wanted to show you was here, a year before that, we had a two-state exercise, Oregon, and I'm going to zoom out a little just to give you context. Here's Northern California. You can see Oregon. Oregon and Washington did a Cascadia Rising tsunami exercise. And so California, because that kind of event would undoubtedly affect us down here, also participated. One of the things that we wanted to look up to follow on that contamination plume conversation was, how do we combine different plumes of data coming from different agencies? What's involved, and can we do it quickly? And so here in Eureka, in Humboldt County, we had plumes coming from the county, plumes coming from the National Guard, and plumes coming from the California Department of Public Health. And what we learned from it was then how easy or not it is to bring it in and how much time it takes. And there's a lot of work that we still need to do. But again, the point of exercises so that we can start to understand that and then how to share it out. So I've shown you that information. Some of the other things I wanted you to see was here we are with the National Guard. We're looking at, they're looking at spot-on response, which is taking feed through XchangeCore. They're looking at the data and figuring out, live coming from the field, what events are being shown. And I'm sitting in a room next to them with some of the other analysts. I'm going to zoom back here, where here we are in ArcGIS Online. We're combining their data with this other feeds of live data that are coming in and data that's being modeled, such as the plume data that you can see. I mentioned the airports that are being shown and which ones are on and off. So again, it was a great opportunity to look at data going both ways. And the National Guard in particular is such a big supporter of enabling this and developing it. We have a long way to go, but they're a great partner for trying to figure out how do we get information from our systems into their systems, and their systems, which have an incredible wealth of resource of imagery data, model data, analytical data about damage information, and then, of course, all the response that they do. So again, we're using a common tool, in this case, ArcGIS Online, and you can see here we're combining the information. The simulated earthquake model of shaking is in the back. And I think that's what I wanted to show you in this regard. Let's see. So I've shown you then the California earthquake where we used it in the Napa earthquake that we had. We were bringing up live feeds of, again, the California Earthquake Clearinghouse staff going out in the field, They were taking lots of information out in the field, photographs, and making it available through XchangeCore, and then we would read it into ArcGIS Online. And then, of course, we used the data most recently, this data sharing in these October California fires that we had. And one of the things that we did, and I'll bring up that one here, is one of the things that we were trying to do is, what you're looking at here is Northern California near Napa, California, which is just above the Bay Area. These are the perimeters of the fire. And one of the things that we recognized right soon after the fires started was that there are hazardous material regulated sites within the fire perimeter, and they're scale dependent, so they don't come on until I zoom in enough. But from a state agency's database, they're called SIRS, you can take this data set and process it and bring up, well, which of these hazardous materials sites are within the fire district. It's needed to know for the people that are responding, our CAL FIRE, our county fires, and many other agencies that are coming to put out the fire. But then after the fire's over, you know, everything's burned to the ground. There's nothing but shells of buildings, and the placards are probably gone. But you still need to know where this information is, and what's with, you know, what you need to watch out for. Am I in an area that has a potential of hazardous material contamination? So we've been working on being able to display more information like this, being able to push it out so that people can see it. So that was the most recent thing just a couple months ago, again, from the October fires. I think I've shown you what I wanted to show you, is that how to process GeoJSON file into ArcGIS Online, and that you can do different things with it. I've shown you our usage of other data in our various exercises and real events, and how we bring it together, and how being able to discover other feeds of information through spot-on response. Other agencies that will model data like NASA JPL, they have models that run both seismic shaking and figure out the probability of damage on infrastructure, and then they'll put the ratings of what the probability is into a data set, and we're able to discover it again through XchangeCore and spot-on response, but we're able to add that live feed of data to our common operational picture. And so the only other thing I wanted to show you was what we had done in Southern California, and we're getting ready for, this is, how are we doing on time? 9:30. This is, again, the south part of the bay, and next year the USGS will have a Hayward fault. It's starting right now, but they'll have a Hayward fault exercise, and many agencies are going to participate to give you a feeling for, here's the Hayward fault running through Oakland and Berkeley. So in this next year, we're reaching out, and again, this is many of my colleagues reaching out to our GIS colleagues and other decision makers to make them aware of, here are resources that are available to them to use them, but using them during an event for the first time is not the time to do this, that you need to get familiar with the data. You really need to get familiar with the people who are creating the data. So the data that they create, you know a little bit about how they're creating it, which ones are authoritative data. We often end up with 2 or 3 different data sets from different agencies on the same theme, such as transportation, which roads are open and which are closed. And it's important to understand how to use them and how to use them properly. And again, what I wanted to show you in this little event was, here's the simulated damage of outage coming from Santa Clara Water, but that what we've been able to do is to read a live feed coming from Santa Clara Water system in through XchangeCore, and I'm able to add it to my data set. And the latest output was, it looks like 11:29 yesterday. So this is looking at live feeds coming from a utility. And out here, give me a second for a quick drink here. One of our efforts in this next year and this last year have been to reach out to utility agencies and ask them to, you guys create often feeds of data for your own web maps that you make available through the public of outage areas, and data like this, could you make them in a common format, GeoJSON, so that we can bring them into our own systems and use that. And what we're trying to do then is to look at, okay, we can see what the potential areas are. How does that relate to the healthcare for facilities? We want to know what healthcare facilities that I've turned on here, or of those, which ones are dialysis, so that we can see where these outages are, what the relationship is to that. And then, agencies like the utilities can then prioritize which ones they need to fix first based on the risk to either critical infrastructure, such as these healthcare facilities, or other data, for example, the nursing homes. Because once you start combining these different data sets and you understand where they're coming from and what they represent, you can do a lot of analysis to give decision makers information that they need, which is often, to help agree on a priority of what we need to fix first and where resources should go. Sometimes the resources are just going to enable people to be able to access these areas. But again, an ability to bring together a lot of this information is important. So I think what I'm going to do is I gave you an idea of how we're using it out here in California with the Earthquake Clearinghouse and the many partners that we have. I just wanted to summarize some of our takeaways, is that it's really important to have your decision makers understand and provide time for analysts to work together, not just in their own agency for their own analysis capabilities, but also at times, especially in our state agencies, to reach across and have other agencies meet together across disciplines and say, here's how we use your information. We need to be able to do this with it, because sometimes their needs are different than an agency's own needs. And that is really important to being able to use the data appropriately, to meet the people, to understand their data, to know where the sites are that are going to provide that information. And then you need periodic meetings and exercises to practice it. And one thing that we've done out here a lot is that we have, and you can find it on the Earthquake Clearinghouse's site, is to develop after-action reports that summarize what worked and what didn't. And I absolutely will tell you there's a lot of things that we need to practice, that getting data from the field out in a normalized way so that damage is categorized in a standard format and can be discovered is something that we still have a lot of work to do. But every both exercise and real event, there's many groups of people that are working together to try to figure this out. And why I was really interested in presenting this to this larger group through the U.S. was to get your feedback, because whether it's right now in this next hour or whether you contact me later, we're really interested on what works and what doesn't work for you in sharing information, developing the data, and best practices. So Jim, I think that's pretty much what I wanted to say. Can I leave it back to you?
Sure, that's terrific, Phil. I really appreciate that, all the different insights that you offered there. But I did want to show one other thing that is just at the beginning. And I see Ron Robbins, who runs the FEMA's National Business Emergency Operations Center, is online there. And this is for you, Ron. You've made this request a while back. And this is another way to look at that GeoJSON data. You can actually take it and bring it into an Excel spreadsheet. And this spreadsheet, it's called Sabre to Excel, and it says click data, refresh all, save as a new name, and you're done. And I'm going to do that now. I've grabbed it. I'm going to click refresh all. Down at the bottom, you see this little spinning world that says running background query. And what's happening now is it's going off and getting that same current GeoJSON source data that Phil went out and got when he pasted that URL into his browser to be able to display that and then move into ArcGIS Online. This is going out to that same source, buried back in here in this Excel, is that URL. And it's going out and pulling the data, but instead of processing it into something that ArcGIS Online uses, Excel is processing it into a format that you can use in Excel. And what that allows us to do now, using this brand new GeoJSON output, is get what is such an important part of the world that we often lose sight of because the GIS stuff is so cool, is an awful lot of the world is non-geospatial. Somebody wants to come in here and take this data and make a pie chart out of it and show as Robbie Bagby, who's on the phone here, who did that as part of his web app that he built out of the Esri tools, he included a little pie chart down there so you could see the rough and relative relationship among all of the different stores that happen to be out. So here we've now popped this up, and that same 700 and what was it, 770, different stores are now all part of this spreadsheet. And if I want to sort them by name, I can now come in here and say what I want to do is, so whoops, that was filter. I want to sort data. Yes, there we go. I want to come to sort from A to Z. So I've got all my Macy's together, and I've got all my Best Westerns there and my BP oils. So if I want to come off there and do some type of an analysis about those, I would be able to do that. If, as Phil was talking about, we've got all these Macy's here. If I decide what I actually want to do, and this will make no sense, but I'm going to sum their object IDs. So if I come down here and go all the way through all the Macy's and find all my Macy's there, and I can tell you now that I have 14,891 completely irrelevant numbers. But you have all the capabilities, as you see over here on this side, of Excel once you get this data in there. And in this one, we didn't pull out all that data that Phil was showing you. There are about 20 more columns off to the right, but just for this quick look of something that is still emerging right now, and we'll probably do a webinar on this in the next couple of months as we get a little bit more sophisticated. But when we're ready to go, you'll be able to download this spreadsheet right off of the Sabre website, hit the Sabre URL automatically just by coming in here and clicking on data and clicking on refresh all, and you will have the latest data in a non-geospatial spreadsheet, easily manipulated form. So just want to show you the extremes from all the beautiful stuff that Phil showed to these very mundane lists of information, which nonetheless are valuable and give you the resources and tools to be able to grab that information. Bobby, I just opened your mic in case you had anything to say, since you spoke to us last week and are a fellow GIS person.
Is there going to be a kind of like an extent attribute in the URL that we can apply to the JSON API in order to just get like our state or, you know, just a specific geographic boundary that we want to get data for?
Yes, Robbie, all the same parameters that you used when you got that information before for your application are also available in the GIS. So you can go in there and do the bounding box for Georgia, and you'll just get the Georgia GeoJSON data.
Okay, will there be a user guide that will have all those, all the information that we need in order to bring the feed in for GeoJSON?
Yeah, the Sabre Users Guide has that, and literally there's a few changes to it, but we'll be updating the Sabre Users Guide with that information.
Okay, thank you.
Okay, Ann, go ahead, Ann.
So this is Ann Greenhouse, and so one of the things that Phil has been working on with the clearinghouse is there's two aspects to data coordination. There is the sort of, you have to have the pipeline in place, which is XchangeCore, and then, what do you do with the data when you have it? And so we've been really trying to develop best practices on educating the field scientists. So as Phil mentioned, we need to be better at naming conventions and reporting in standard ways so that the information is more actionable, because scientists, they're out measuring grain size and nobody cares about that. They want to know, is the ground going to, be strong enough to hold my repair truck or something like that. So the ability to be working with the JSON is an important carrot to our scientists and engineers who are out collecting data, because then they have more useful data and more can use the information that's collected from others and bring it into the observations about the scientific impacts to assess what's going on. And for the Napa earthquake, that was really important. Afterslip was a interesting phenomena that happened, and for those of you who aren't familiar with it, the earthquake happened at, I don't know, I can't remember, 3:40 in the morning, but the ground continued to shift, over the several days after the earthquake, and that led to continued water line breaks. And so for the scientists to be able to see where those breaks are, where they're happening in real time, gives the scientists an idea of what's going on with regional deformation and the fault, and then the scientists can go out and look at it, and then in return provide observations back saying, hey, initially the ground shifted 5 centimeters, and 24 hours later now it's shifted a total of 20 centimeters. So being able to share that information and bring those different pieces of information together using the JSON function is, it's really important, and Phil's been a lead in developing those capabilities. So,
thank you, Ann. Appreciate that, and also thank you for your sponsorship to get part of this JSON out and in production value. Don't see anybody else hands raised, so let me just say that you've got contact information up on the screen, even though I know you're probably besieged by our emails, and want you to know that we are looking forward to continuing to grow, not just the GeoJSON, but other capabilities that are there inside of XchangeCore, and make them available to everybody as part of our commitment to this whole information sharing community. So let me thank Phil very much. Great presentation, Phil, and very much enjoyed that myself, and I'm sure everyone else did. And take care, everybody.